Hello students, today we are going to discuss when to apply Cauchy's integral theorem and Cauchy's integral formula to the problems. The Cauchy's integral theorem states that if f of z is analytic inside and on a closed curve C, then its integration f of z dz is equal to 0 along the closed curve C. So if it is analytic inside and on a closed curve C, then its integration value is equal to 0. Whereas Cauchy's integral formula states that if f of z is analytic inside and on a closed curve C, so up to here the Cauchy's integral formula statement is the same. But we have the point extra condition here is, and A is a point inside C. Then integral over C f of z upon z minus a dz is equal to 2 pi I multiplied by f of a. So if A is a point inside C, then Cauchy's integral formula is f of z upon z minus a integral over c dz is equal to 2 pi I multiplied by f of a. So the difference between Cauchy's integral theorem and Cauchy's integral formula is this condition. A is a point inside C. This is the difference. So this point A is called the singular point. Why? Because z minus a, if it is equal to denominator becomes 0, then this integrand f of z upon z minus a becomes at z is equal to a, it becomes infinity. So therefore, z is equal to a is a singular point because at this point the function cannot be analytic. Z is equal to a is a singular point because at which the function fails to be analytic. So therefore, it is a singular point. Now this singular point A lies inside C. This is the Cauchy's integral formula states. Whereas in Cauchy's integral theorem, there are no singular points. That is the main difference between Cauchy's integral theorem and Cauchy's integral formula. There are no singular points. If at all singular points are there, then they will be outside the curve C. Here, if at all singular points are there, they are inside the curve C. If the singular points here in Cauchy's integral theorem, the singular points, they can be outside or there are no singular points. In such cases, we use Cauchy's integral theorem. If a singular point lies inside C, we use Cauchy's integral formula. So I hope you understood what is meant by a singular point. Singular point means where the function fails to be analytic. See here, it is f of z is already analytic. Z minus a being a polynomial, it is also analytic. F of z upon z minus a being a rational function, it is also analytic, except at the point a because the denominator becomes 0. At z is equal to a, the denominator becomes 0 and hence the function does not exist. So z is equal to a is a singular point here. And this singular point lies inside C. It lies inside C. So in such cases, we use Cauchy's integral formula, where singular point lying inside a curve. And if there are no singular points, or if a singular point lying outside, then we use Cauchy's integral theorem, where Cauchy's integral theorem, its integration value is equal to 0. Where Cauchy's integral formula, f of z upon z minus a dz is equal to 2 pi I multiplied by f of a, where f of a is nothing but f of z, the numerator z is replaced by a, where the numerator z is replaced by a, this part, f of z, where the numerator z is replaced by a. Okay, so if there is a singular point inside a closed curve C, then we use Cauchy's integral formula. If there are no singular points or a singular point is lying outside the closed curve C, then we use Cauchy's integral theorem. Where if you apply Cauchy's integral theorem, its integration value, complete integration value is 0. If you apply Cauchy's integral formula, it is 2 pi I multiplied by the numerator where z is replaced by a. It is the answer for the integration. I hope you understood.